Okay, so let's see what we have to do today in LabVIEW. So we are going to look at the comparison functions. Comparison functions are functions that are used to compare two values, and based on that comparison, a result is generated. So functions like greater, if you're comparing two values, if one value is greater than the other value, or equal, less or equal, greater or equal, all those functions are called comparison functions. In addition to that, the functions that are Boolean functions that are also used to generate a result based on the type of input that is coming in. For example, if you're comparing two functions and you want both functions to be true. So if, let's say, A is greater than 5 and B is greater than 3, then do something. So that and between the two comparison function, that's a Boolean entity. So we are going to look at those Boolean functions as well. And comparison function and Boolean functions, both are used basically to, as I said, generate results based on the comparison and to do some function in your system, in your control system, when you're comparing two values or comparing two entities. And they're very commonly used with if loops, while loops. We are going to discuss while loops today that keep doing something while these functions, these comparison are true, or keep doing something while these comparative functions yield the false value. So you can choose the true value or the false value. And as soon as the comparison function basically generate either the true value or false value, then stop doing what the program is doing. So those are the loops that are called while loops. While something is true, keep doing these things. Or while something is false, keep doing these things. And while loops are very commonly used when you are trying to accomplish a goal, but you do not know how long it is going to take you to accomplish that goal based on some condition. In those circumstances, and while loops are in every programming language, including LabVIEW, which is a graphical programming language, and in all the procedural programming languages, you take, from very beginning, you take basic language, you take Fortran, you take Python, you take C, C++, MATLAB. Every programming language you will find while structure. And you will also find for structure. So for and while loops basically are pretty much in every programming language. For loops we are going to discuss next week. And today we are going to discuss while loop and how do we use while loop in conjunction with comparison function and Boolean functions. And the other thing that we are going to look at are the random number generation, as how you generate random numbers in LabVIEW. There are multiple blocks that are available that generate random numbers. So we are going to look at those blocks. So that's the plan for today. And I'm going to open LabVIEW and then we will discuss some program, but let me just move to the page where. So 6 was the last exercise that you did. And then we're going to start working with the comparison function. The first function we are going to look at is what we call the switch. This is the switch. So we're going to look at the switch. And let's see, random number. We're going to look at the blocks that generate random number. And then we are going to look at while loops. And finally, we are going to look at the Boolean functions. And there are multiple exercises that you have to do, 9, 10, 11, and I believe 7 and 8. So 5 exercises that you have to do. 7 and 8. Okay. So let's open LabVIEW. Let me share my whole screen. I'm only sharing my PDF file. Share whole screen. Let's go to LabVIEW. Is LabVIEW working for everyone? Robert, is your LabVIEW working?
It is working.
Okay, good. Okay, so let's start applying VI. Interesting. Okay. So the first thing that we are discussing are switch functions. So switch function is used based upon, let's say you are evaluating an expression based on X and Y. And either you can evaluate one expression or you can evaluate the other expression. And if you want to choose between the two, that which expression you want to evaluate, there are two ways you can choose. Either you choose manually that you want to do one expression or the other expression, or you can choose based upon if one input is greater than the other input or less than the other input, and so on and so forth. So let's say we have a numeric control and another numeric control. And this is my X, and the other one is my Y. The other one is my Y. And let's say you want to evaluate two expressions. You want to evaluate f1 of xy equals 2x plus cosine of y, cosine of xy, let's say. And then you want to evaluate another expression, f2 of xy, that is the function of x and y, equals 3y plus sine of 2xy. So let's say you want to evaluate these two expressions. Let me go ahead and make them bigger. I can also put both block diagram and the window right and left by going to window, and then you can choose tile left or right or tile up and down. So you can see both of them at the same time. So let me do that. So you have this expression, and then you have this expression. So you have two expressions. And you can choose what type of logic you have to apply in order for you to calculate the first function or the second function, because both are the functions of two variables, x and y. And either you can choose to calculate the values from the first function for the given values of x and y, or you can choose to calculate the values of the second function based on the values of x and y. You can calculate both values, of course, but let's say if you have to display and choose only one value based on some condition, that's what we are going to look at, how to carry out the conditional response based on the values of x and y, or based on your choice. So the first thing that we are looking at is, of course, we have to put a numeric indicator in order to see the value, the calculated value, either from the first function or the second function. And of course, in my, let's say this is my exercise 1. And remember, you have to put a brief description of the, I'm not putting any description right now, but when you are representing your control system, remember, you have to put a brief description of your exercise, just a line as what this exercise is about, or what this system is about, because you're presenting this in front of an audience, remember. So this front panel goes in front of the audience, not the block diagram. Now, this is the first thing that I'm going to show you is what we have, of course, in the tutorial as what is the switch function. So take this here. Let me first go ahead and I'm going to just use formula block right now. I mean, I can program each function, of course, individually using individual blocks. But instead of doing that, I'm going to use the formula block just so that it is quick. And I have two formula blocks. First formula block to represent the first function. So I'm going to put x and y. And the first function is 2 times x plus cosine x times y. Why it is not? Let's see. Why it says invalid formula. X, y, 2x plus cosine x times y. Okay. Why it is saying invalid formula? Okay, because of the spaces that I put between the plus sign. So don't put any spaces. So now it's the valid formula. And I'm going to show that this is f1 of xy. To represent, this is a formula block for f1 of xy. You can change where the formula is written on the formula block. You can change the text so that you know that this is the formula block for what. And then I'm going to put another formula block and I'm going to write down the other formula. Let's see if I can copy and paste it. Control C, Control V. And this is going to be my f2 of xy, which is 3y, 3 times y plus sine of 2xy plus sine of 2 times xy. And this is my f2, so I'm going to write down f2 of xy. Okay. So x is connected to x, and y is connected to y. And likewise, my x is connected. Let me take it here. My x is connected to x, and my y is connected to y. And the result is going to go in the numeric, but since I have only one input in the numeric indicator, of course, I cannot combine the two results and put it in the numeric. So now I have to apply logic. And the first logic is that I can choose one of the functions. And that choice, in general, is coming from a block, which is called a switch block. So the switch block is going to be, let's see, I have to go and search. I always forget where the switch block is. Switch. So the switch block is under structure, execution block. Let's see. Case structure. No, that's not case structure. Let me go back and check where the switch block is. All right, mathematics elementary exponential library. That's where the switch block is. Mathematical exponential elementary and exponent, not exponential. Oh, that's the log 10 function. That's where the exponential is. Okay, let me find the switch block. I usually forget where the switch block is. It's in the comparison, most likely comparison. And later, let's select block, not switch block. I keep calling it a switch. It's a select block. So it's in the arithmetic and comparison and comparison function. So select block. So I'm going to go ahead and, because we have to select one of the functions, I'm going to go ahead and, oops, where did it go? Select. I'm going to go ahead and put it here. And I'm going to visible item label. I'm going to show you that. Okay, now select block, since it's a new block, you can look at the help. Now select block help used to be, now it's online, but it used to be part of the LabVIEW, but it's good that it is online now, so it does not occupy a lot more room on your hard drive or any place where you are saving the program. So all the help is available online. You can do right click of any block on any block and then press the help. It's going to take you to the help. So observe the switch function. It has three inputs. The top input is true, T, the bottom input is false, and the middle input is the select. I keep calling it switch. It's a select block. The middle input is select. Now, whatever is coming at the middle input, if that value is 1, then whatever is connected to the true input is going to be transferred to the output. And if at the select input, the value coming is 0 or false, then whatever is coming at the false input, that is transferred to the output. That's how the select block works. So it works as an if condition. In LabVIEW, you don't find an if condition, but this is an equivalent of if condition. In other languages, you will see if conditions. If A is greater than 0, then do this, else do this. So that is equivalent to the select block in LabVIEW. If the condition that is coming is 1, then transfer true to the output, whatever is coming at true input. And if it is not 1, that is if it is 0, else, then transfer whatever is coming at false to the output. This is how this block works. So to do that, we can do two things. We can either manually control it. So first I'm going to put basically a switch to manually control it, as I'm showing you again in the tutorial. Why? Arithmetic and comparison, express, input. Oh, so it's looking at the wrong place. Switch is in the control library, because that's your part of your signal. So I'll go switch. So this is the switch that is going to be used in order to select either F1 or F2. And that switch is right here, Boolean. And that I'm going to connect to the middle part. The top one is going to be connected to the result of F1, and the bottom one is going to be connected to the result of F2. So once you run this program and you just select either you want to calculate the equation corresponding to F1 for xy or calculate it according to F2 for xy. So this is you're manually controlling the output. One of the outputs is going to be displayed. One of the function is going to be displayed. If you don't want to calculate it manually, if you want to put a condition, let's say if you want x is greater or equal to y, x is less or equal to y, x is greater than y, x is less than y, any condition that you want, you can also do that instead of the switch. Let me stop this execution. Oh, switch, I always forget switches here. Instead of the switch, you can put a comparison function. So where are comparison functions? Comparison function, again, they are in the comparison library. And all these functions equal, not equal, greater, less, greater or equal. All these act as comparison function to compare two values and generate either a 1 or a 0. Comparison function, they're Boolean functions. So they generate either 1 or 0 based on their input values. So let's say if we want to do greater or equal. If x is greater or equal to y, then generate the true result. And if x is less than y, then generate a false result. So if I connect x to the top and I connect y to the bottom, then this function, which is greater or equal, when x is going to be greater or equal to y, then it's going to generate a 1. Hence, the output according to f1 xy will be selected and calculated and displayed. And if x is less than y, then the output according to f2 xy is going to be calculated and selected and displayed. So the whole idea is that how you are generating the condition that is selecting the output. Either you're generating it manually or you're generating based on a comparison function. Even the manual generation, the select function is also a comparison function. So if you run it now, right now, y is greater than x. The output is generated according to f2 xy. If x becomes equal to y, remember the condition is greater or equal. So if x becomes equal to y, then the condition that will be generated will be according to f1 xy. And as long as x is greater than y, the condition will be generated according to f1 xy. And if y becomes greater than x, then the condition will be generated according to f2 xy. So this is a simple program to show the utility of using select block as well as comparison blocks. And then the comparison library, again, as you can see, there are so many different comparison functions available. And likewise, if I go back and open the comparison library, programming, I want the express and arithmetic and comparison. So all these can be used. And likewise, collapse this. Likewise, if you go to the arithmetic and comparison and Boolean library, so all these Boolean functions that are here, AND gate, OR gate, exclusive OR, NOT gate, NAND gate, NOR gate, XNOR gate, all of these are also present here that you used in PSpice before. All the gates that you use in PSpice, they are also located in the Boolean library. And the Boolean library, again, as I mentioned, most of the time we are using it in conjunction with your comparison function, such that if two conditions are supposed to be true, then you use AND gate, such that the first condition is true as well as second condition is true, then only the output of AND gate is going to be 1. If either of the condition is not true, then the output is not going to be 1. Likewise, you can choose OR gate, that if any of the condition is true, then the output of OR gate is going to be 1. But only if both conditions are false, then the output is going to be false. So again, based on your situation, what logic you're creating, many times you are using these Boolean gates, Boolean functions, in conjunction with comparison function in order to generate a condition based on which your program is executing. So those Boolean functions are present in that Boolean library. Those functions you already used in the PSpice as well. Let me go to the tutorial and then see. Okay, so this is the same thing, the toggle switch and the select function that I discussed with you. In this case, I'm calculating natural log or base 10 log of the value of x. So I used a select function. And based on if it is true, I calculate the natural log. If it is false, I calculated the base 10 log of the input x. All right, exercise 7 is one of the exercises that you have to do. And in this exercise, you're doing exactly the same thing like I showed you during the, in the programming that we did right now, that there are two functions, 2x plus 3y and 4x plus 5y. And you have to choose one of the functions based on the toggle switch. So you're doing exactly the same as it is shown here, or what we did right over here. As the functions are different, but the implementation is exactly the same. The functions are given to you, which are 2x plus 3y and 4x plus 5y. But the implementation is the same, that you have to use a toggle switch right here, toggle switch. You have to use a toggle switch in order to select one of the functions. So that says it's very simple. Incorporating other comparison function, I showed you how to compare the comparison function as well. Again, if you are implementing this same exercise, but instead of using a select switch, you are using a condition. Again, I showed you how to use the condition, and the condition is x is greater than y. If x is greater than y, then the output is calculated according to fxy. If x is less or equal to y, the output is calculated according to gxy. So that's what we are doing in this exercise. Again, I showed you how to do this exercise as well. I'm doing it here using individual blocks instead of using function blocks. But the idea is same. Instead of using greater or equal, I'm using a greater block over here. So this is another exercise, but just make sure, be very careful that exercise 7 is not based on this exercise. Exercise 7 is based on the previous exercise where you're using a switch to select one of the entities. So many students just copy basically this block diagram and then submit it as exercise 7. Remember, this is there's no requirement in this exercise that x has to be greater than y. The requirement is just that you are manually selecting one of the function with the toggle switch. So do not just copy the block diagram and submit it as exercise 7. One thing in this exercise that I want to discuss is I'm putting two LEDs, as you can see. And the idea is that when whichever function is the value of whichever function is calculated, the LED corresponding to that function is going to be it's going to light up. So if x is greater than y, fxy will be calculated, LED will be light up. And if x is less or equal to y, then gxy is calculated and the LED is going to light up. As you can see in this execution. So y is greater than x, gxy is calculated, LED is lit, and then x is greater than y, fxy is calculated, and then LED is lit. Now the question is, if you look at the block diagram, both the LEDs are connected at the output of your greater block. Now the greater block is going to provide you only either 1 or 0, which means both LEDs should light up at the same time, or both LEDs should not light up at the same time. The question is, how did I, according to this block diagram, how did I make it light up only one LED at a time, based upon which one is calculated? Can someone answer that question?
Does that have to do with the assignment from the homework from last time with the 0 and 1 switch, and how, like, because it's an on signal and an off signal?
So again, observe the LEDs are connected directly at the output of your greater block, right? So greater block is going to be giving you either a 0 output or 1 output. That means if the greater block is giving you an output of 1, both LEDs should light up. And if the greater block is giving you output of 0, both LEDs should be off. But if you look at the execution of my program, when gxy is calculated, LED is lit. And when fxy is calculating, LED is lit. Although only one of the function will be calculated at one time, based upon if it is 1, then fxy will be calculated. And if it is 0, the output of greater block is 0, then GXY is calculated, because the select block is going to let the top one go through it. If the input coming in the middle, then the select input is 1. And if the input coming to the select input is 0, the bottom input is going to go through and display it. But my LEDs are working fine. And this is the block diagram. So the question is how my LEDs are working. They should not be working like this, by the way. They should be either on both of them or off both of them. And the answer of that is cheating. I'm cheating right now. This is not possible. In real life, it's not possible for sure. In LabVIEW, it is possible. But in real life, it is not possible. In real life, what you have to do if you want to make something, make it work, then what you need to do is, let me grab a pencil. Basically, you will have to add a NOT gate over here. You will have to add a NOT gate over here. Why? Remember, what is the functionality of a NOT gate? Anybody remember from PSpice or digital systems if you're taking? What does a NOT gate do?
It reverses. So if it's
Reverses.
0,
exactly, it reverses, right? So if the output of the greater block, if the output is 1, the top LED is going to turn on, but the bottom LED will be off because this NOT gate is going to turn into 0 and the LED is going to receive a 0 signal. And likewise, if the output of the greater block is 0, then the top LED is going to be off and the bottom LED is going to be on because the NOT gate is going to turn it 0 into 1. So without using NOT gate, it is not possible in real life, in real implementation of the project. However, in LabVIEW, I'm doing it. And the answer of how I'm doing it is very simple. The way I'm doing it is basically both of them are on at the same time and both of them are off at the same time. But I chose the color of this LED, the top LED, the FXY LED. I chose the color that when it is on, it appears to be a darker color. And when it is off, it appears to be a darker color. And when it is on, it appears to be a lighter color. Whereas the LED for GXY, I chose then when it is off, it appears to be a lighter color. And when it is on, it appears to be a darker color. So both LEDs are turning on and off at the same time because there is no NOT gate over here. But just by going into the properties of LED and making the off color of GXY to be lighter and on color to be darker, it just appears to anyone who is looking at this system that one of the LEDs is on and one of the LEDs is off. So it's a cheating, as I said. I cannot create this system in real life just by doing that, because I cannot change the physical color of an LED. An LED, whether it's a green LED or red LED, when it's going to be on, it's going to light up. So I cannot change the color. But in this case, I just change the properties and the color. So, all right. So again, this is a program using switch, but using a comparison function and doing some cheating to make it appear that LED is on or off. Although, as I said, you must use a NOT gate in order for the LED that is supposed to be on when the input is 0. Then you have to use a NOT gate with that LED. Okay, random number generation block. Let's go and show you that. There are a couple of random number generation blocks that we can use. And let me show you both of them. So if I put a numeric indicator and this numeric indicator, let me go back to my Express. If I go to arithmetic and comparison, numeric, and there is a function here which is called random number right here. And again, you can always search for random. So there is a function random number block. If I pull this block, they look like a pair of dice. And observe it says random number 0, 1. This block produces a random number between 0 and 1 using uniform distribution. If you don't know what uniform distribution is, don't worry about it at this time. Uniform distribution is basically a type of data distribution in which the likelihood of selecting any number between the two range, between 0 and 1 in this case, it has equal likelihood or equal probability to choose any number between that range. That's called the uniform distribution. So if I connect this to my numeric indicator, and anytime I execute my program, as you can see, it will select a number randomly between 0 and 1. So this is a random number generation between 0 and 1 using uniform distribution. I'm pretty sure it's uniform distribution. Let me confirm, because I know in MATLAB it is the uniform distribution. And it will show us. Produce a double precision for a number. The number generated is greater than or equal to 1. The distribution, yeah, uniform distribution. The distribution is uniform. So likelihood, each number has the same likelihood of being generated. Let's go back. Now, what if you don't want to generate number between 0 and 1? You want to generate number between 0 and 20, 0 and 30, 0 and 17, 0 and 15, whatever, higher limit. It's very easy. You just multiply the output of this by the highest value that you want to generate the number up to. For example, if I want to generate a number between 0 and 17, then I can just multiply that, because this number generated is between 0 and 1. If I multiply that number by 17, that means I am multiplying 0 to 1 times 17. So the lowest range is going to be 0, and the highest value is going to be 17 when it will be multiplied by 1. And between 0 and 17, all the numbers are going to be generated with equal probability. So if I just multiply these two, and now I generate this, then it's going to be generated between 0 and 17, as you can see. So it's very easy to generate. It's very easy to change the range of that. Now, if you don't want double precision point, that is, if you don't want the real number, if you only want integers, then how do you generate integers out of that? Again, it's very simple. You have to round it off. So whatever number is generated, you can round it up, you can round it down, or you can round it off. If you round it up, it's going to go to the next integer. If you round it down, it's going to go to the previous integer. And if you round it off, then it's going to go to the closest integer, whichever is the closest to that real number that you generated. Where are those functions located? Again, those functions are located in the mathematics library. Right here, round. So you have a round functions. So if you want to round this number up, then the output of the multiplication block will be connected to the round function, and the round function is going to go to display the value. If you want to round it up, then it's going to be round towards positive infinity. If you want to round it down, it's going to be round towards negative infinity. So these three functions are round up functions. Round to the closest, round to the previous integer, round to the next integer. So you can, instead of generating precision point number, what we call the real number, you can generate only integers. Instead of decimal numbers, you can generate only integers by rounding the number. This is one of the random number generation function available in LabVIEW. There is another function available. Let's look at that. random. So there's a random number 0, 1 that we use, and there is a random number range that is available right here, which is under mathematics numeric, random number range. What does random number range do? Random number range generates an integer between the lower range and the upper range. So if in case you want to generate an integer between 0 and 17, then you can always connect, let me put the label. So you can connect the top input, which is the upper bound, to 17, and you can connect the lower bound to 0. Or maybe the lower bound, by default, it is 0. If you want to generate between 0 and 17, then I think let me try, or you can try later. Because the lower bound by default, it shows 0. And the upper bound by default shows 100. So it can go between any random number between 0 and 100. Now the question is, if you want to go from 0 to 17, do you have to connect the lower bound or not? Perhaps yes or not. You can, again, if you're using the block, you can see if it is generating numbers between 0 and the upper bound without connecting 0 to the lower bound. But in general, whatever, let's say you want to generate a number between 5 and 10. Integer between 5 and 10, not the number, not the real number, not the decimal number, but integer between 5 and 10. Then the lower bound will be connected to 5 and the upper bound will be connected to 10, and it's going to generate random integer between 5 and 10. So this is how this block works, random number range. So these are two blocks in LabVIEW that generate random number. One can generate decimal numbers between 0 and 1, and you can, as I said, multiply it by n number to generate decimal number between that number and 0. And one can generate only integers between the lower bound and upper bound. Between 0 and 100 are the maximum values. Lower bound 0, upper bound 100. So these are two random number generators. If you look at exercise 8, I'm asking you use both random number generators, that is the one that we discussed in the class, to generate a pair of random integers between 1 and 10. So you have to generate integers between 1 and 10, and you have to use both of them. So you're going to use random number range 1 to 10 and generate random integers between 1 and 10. And then you're going to use, in the same program, you're going to use random number range block and generate the random integers between 1 and 10. So you're going to have basically two numeric indicators. The top numeric indicator is going to be showing you numbers generated from random number 0 to 1 block, converted into integers between 1 and 10. And the bottom numeric indicator is going to be showing you number generated through the range block, again, between 1 and 10. So simple program. I already showed you how to do that. Shouldn't be any problem. If you have any questions so far, please go ahead and ask. All right. If there is no question, let's go ahead and look at the while loops then. All right. What are while loops? So if you go, let me go back here. So while loops, so this is exercise 2, let's say. Exercise 2. And I'm going to delete this because it's not connected anywhere. So it's going to create an issue. All right. What are while loops? So let me give you an introduction of while loops and then show you how to use it, or go over the tutorial and I'll show you. Different type of programming structures are present under programming, including while loop, under structures, including for loop, while loop, case structure, timed structure. All these type of different structures are present under programming and structures. We are using only two, for loop and while loop, in this course. While loop is when you put it in the block diagram, and it's a programming structure. It's there to create some logic So it's not part of your front panel, it's part of your block diagram because you're using it to create some logic. So it's gonna appear like this, and you can expand it as much as you want. There are two buttons, as you can see, or two entities, I, which is called the loop iteration, and then this is the stop button, which is the loop condition. That is when the loop is going to stop. By default, there are two conditions you can set: when the loop is going to stop, or if the loop, you want the loop to be continued. And what are those conditions? If you do the right click, the two conditions are stop if true and continue if true, or stop if false. So you want to stop the execution of the program if the condition becomes true. While loop works on conditions, that if one condition is greater than the other condition, then either keep the loop going or stop the loop. Or you can choose stop, continue if true. You can just toggle it by pressing the button. So if it shows the continuous sign, that means it will keep on working as long as the condition inside the loop is true. And if you choose for the loop to stop when the condition becomes true, then you will be a stop sign, that when the condition that you're setting for the loop to keep running becomes true, then the loop is going to stop and the final results are going to be generated from the loop. So this is your while loop, and start the programming and structures. Let's go to the tutorial and show you how I'm using while loop. So in this program, I'm creating a program in which I'm asking user to enter a number between, I believe, 0 and 10, or 1 or 10, 0 and 10, between 0 and 10. And the program is generating a random integer between 0 and 10 using the range block or the random number 0, 1 block, and I'm rounding it off between 0 and 10. So the idea of this program is the user is entering a number, an integer, and as soon as the user is going to enter the integer that is randomly generated, that is, as soon as user is going to guess the number that is randomly generated, the program is going to stop and the light is going to turn on, which shows that the number that was generated is matched with the number that user has entered. That's the whole idea of the program. So it's basically a guessing game, that I guess a number between 0 and 10, and then you have 10 turns or 9 turns. In this case, there are no number of turns that we are doing, but we can put number of turns as well. But in this case, there is no number of turns, but you are guessing number between 0 and 10. And the maximum number of turns you're going to take, of course, are going to be 11 if you are going from the sequence 0, 1, 2, 3, 4. And if the number generated is 10, then at the 11th guess, you're going to guess that number 10. So the number of turns can be anywhere between 0 and 11 if you're going in sequence. If you're just putting random numbers and repeating random numbers, then you can take as many turns as you want, as long as the number is not matched properly. So this is the idea of this program. It's a number guessing game. So this program is created using while loop and conditions. And very simple program, as you can see the block diagram. So in the block diagram, you can see that I'm using, in this case, I'm not using the range block. I'm just simply using the 0 to 1 random number generation between 0 and 1, multiplying it by 10, and then just rounding it off. So rounding it off means that it is going to, so here you're gonna have numbers between 0 and 10 because it's multiplied by 10, and it's going to be decimal numbers. But once I'm going to round it off, the number generated here is going to be integers between 0 and 10. So this is going to be integers between 0 and 10. This is going to be decimal number between 0 and 10. So once the number is generated, then I take that number in the while loop, and I have an equal comparison function. So this is equal comparison function. And here is my user input. So I'm asking user inside the while loop, I'm asking user to put your input. And user is putting his or her input. And as soon as both inputs of the equal block becomes equal, the output of the equal block is going to be 1. And that one is going to stop this while loop. And at the same time, that one is going to light up the LED to show that the numbers have been matched. So extremely simple program, but there are two things that you need to understand properly here. While loop, anything that is inside the while loop is going to be repeated that many times. Anything that is outside the while loop is not going to be repeated. That's first thing. Now, in this case, my objective was to generate the random number only once, and then let the user guess that number. And that's why you see I generated the number outside the while loop. Because if I do the generation inside the while loop, then every time while loop is going to run, it's going to generate a new random number. So that's the first thing. Anytime you're using while loop, anything that you do not want to repeat has to be outside the while loop. Anything that you do want to repeat every time the loop is going to run, you want to repeat something, those things are going to be inside the while loop. So in this case, I don't want to keep generating the random numbers. I only want it to be generated once. That's why I put the whole generation mechanism outside the while loop. However, I want the user to keep guessing until the user guesses the correct number. And therefore, the user input or user guess is inside the while loop. Now, based on the same idea, and we discussed Boolean functions already, so I'm not going to go over that right now. Let me go to the program that you're using right here. But perhaps go over the Boolean. We already discussed the Boolean function and or NAND gate in PSpice. And I showed you the library where you're using the Boolean function. In this one, basically, we have two dials and we have two LEDs. And the idea is if dial A is greater than B, then LED of A will be on, and if dial A is less or equal to B, then LED2 will be on. So here I'm using, of course, comparison function. A is greater than B, and observe I'm using the NOT gate. As I mentioned earlier, that you will have to use the Boolean function in order for only one LED to be on at one time. So I'm using a NOT gate over here. If the output of the greater block is 1, that is A is greater than B, only the A LED is going to be on. And if the output is less or equal to B, then the bottom LED will be on. If I connect both of them directly, then both will be on at the same time and both will be off at the same time. So I used the NOT gate over here. All right. And we just have 3 exercises and then we are pretty much done for today. So it's a short class. Matrices and arrays next week. And then your graphs. Okay, so not that much work is left for next week. Okay, let's go back and discuss 3 exercises that we have. All right, exercise number 9. Create a program that can generate random integers from 3 to 8. Your front panel will have only one numeric indicator to show random integer. Now, I want you to not mix this exercise with other exercises because you're using while loop. And sometimes it happens that if your while loop condition is not met properly, it can keep on running forever. And if that happens, then your whole program can hang, basically. The other exercises are not going to run. So my advice is you can do exercise 7, 8, 10, and 11 in one VI, as one VI, and exercise 9, just make it a separate exercise. So in case if exercise 9 is hanging up or something, then at least other exercises are working properly, although I hope exercise 9 will work as well. But do this separately. So do this separately, and rest of the exercises you can do in a single VI file. Okay, so what is exercise 9 as you read? You are generating from 3 to 8. Now, you're going to say that, oh, it's very easy to generate from 3 to 8. I'm going to use the range block, and I can connect the lower range to 3, upper range to 8, and boom, it's generating from 3 to 8. But that's not the purpose of this exercise. The purpose of this exercise is to use while loop, so you can do some exercise with while loop as well. And also, the while loop should be a working while loop. That is, your program should not execute without while loop. So the idea of this exercise is that you should not use the range block, first of all. You should use the random number 0 to 1 block. That's the first requirement of the program. And the second requirement is that you must use while loop in order to make the program work. And without while loop, the program should not work. Remember, this can be done in 2 or 3 different ways. But these are the 2 requirements of the program, that without while loop, this program should not work, and you should not use range block. Because range block is going to give you anyways between 3 and 8, you don't have to use while loop. But even without while loop, you can also use the random number generate block to generate a number between 3 and 8. Very simple. I'm not going to explain how, but it's a very simple process. But then again, the while loop purpose is going to be dead. Then the while loop is not doing anything. So the while loop must be an acting while loop. That is, without while loop, your program must not run. That's the main requirement of this exercise, remember. So simple exercise is not difficult. I can give you some hint that you are using random number generation 0 and 1 block. The highest value is 8. You can set it that it can generate values from 0 to 8. And then you can use a comparison function to see if the generated value is above 3. Its generated value is above 3. Or you can generate from 0 to 10, and you can use 2 comparison block to see if the generated value is less or equal to 8 and greater or equal to 3. And if that is true, if both conditions are true, then it's going to stop the while loop and it's going to display the value. So you're going to use a numeric indicator outside the while loop in which the number will be displayed. So as soon as you keep running while loop, you run while loop one. So with while loop, you don't have to keep running constantly, because while loop itself will keep running. Even if you run only once, it will itself keep on running as long as the condition of the while loop is not met. So it can run 10 times. Just for you to run the program once, it is possible it will run 10 times as long as the condition is not met. So you don't have to keep running it continuously. Just run it once. And the whole idea is, if the condition is not met, then it's going to generate another number and then check the condition again. If the number generated is between 3 and 8, the condition is met, it's going to stop the while loop, display the number. If it is not met, if it is below 3 or above 8, then it's going to run it again and then check it again. So I have seen in the past that some students did not program it correctly, and they programmed it such that their condition is never going to be met. So that means their while loop will keep on running always. And again, as I said, that will hang the rest of the program. So I had to go and delete their exercise 9 in order to at least check their other exercises. They did not receive points for exercise 9, but at least if their other exercises are correct, then they can get points for the other exercises. But exercise is very simple. Give you some more hints. Remember, in the example that I showed you for the while loop, we are generating the number only once. Here, if your condition is not met between 3 and 8, you have to regenerate it. Which means where you're going to put the while loop block. I mean the random number block. Who's going to tell me? Where exactly you're going to put the random number block?
inside the while loop?
Inside the while loop, very good. So you're going to put it inside the while loop, because if the condition is not met, then you have to generate another random number. And then another random number. As long as the condition is not met, that the generated number, integer, not number, integer. If the generated integer is not between 3 and 8, you will have to keep running the while loop. So each time the loop is going to run, a new number will be generated. So in this case, it has to be inside the while loop. And then again, you're going to create the comparison logic, and then check, and then stop the while loop only if the condition is met. That is, the generated number is greater than 3, or greater or equal to 3, or less or equal to 8. So I hope you understand what you're doing in exercise 9. Exercise 10 is kind of similar to this exercise with a little twist. So in this exercise, A is greater than B, A light will be on, A is less or equal to B, B light will be on. In this case, you have 3 dials, A, B, and C. And each dial goes from 0 to 10, which is a default value of each dial, by the way. And you have 3 LEDs for each dial, 1 LED for each dial. And the idea is that the dial that has the highest value the LED for that dial should turn on. And if the dials have equal value, all of them are 1, all of them are 0, all of them are 5, or whatever. If the dials have equal value, they should not be on. None of the LED should be on. So the LED should be on only for the dial that has the highest value. Now, how you can put together this program? So again, you have to think about the logic based on what is the requirement of the program. Because if you understand the logic properly, then you can program it in any language, any syntax. That's not an issue. But if you don't understand the logic, then you won't be able to design it or write the code. So the logic is what? Logic is, if dial A is greater than if dial A is greater than B and greater than C, both. If dial A is both greater than A and C, then the LED for A is going to be on. And the same goes for B and C. If the dial B has the value which is greater than A and greater than C, then dial B will be on, and same goes for C. So you are comparing each dial with the other 2 dials. And the only way the LED should be on if the comparison between the 2 greater function are going to be validated, are going to be true. So I'm putting a hint over here that you can use AND gate as part of your design. Because AND gate, remember, it works if both inputs are 1, the output is 1. If either of the input is 0, the output will be 0. So in your case, when you're doing the comparison of each dial with the other 2 dials, if the dial has greater input with respect to B, let's say A dial, and with respect to C, only then dial A light should be on. So the logic is very simple. The implementation is very simple, again, but you just have to understand the logic that this is what you're doing. So that's your exercise 10. Whatever logic you're applying for A, you're going to apply the same logic for B, and you're going to apply the same logic for C. So the logic is repeated for each dial. It's the same logic, but repeated for each dial. All right, and the last exercise for next week is I'm giving you a digital circuit similar to what you did in PSpice. You didn't do this exact circuit in PSpice, but similar circuit you did in PSpice in the exam as well as in the exercises. And what you have to do in this, on the front panel, you have 3 switches, A, B, and C. And an output LED, which is X. So that's your front panel. So in the front panel, you have switch, the toggle switch or whatever switch. So this is the toggle switch A, toggle switch B, and toggle switch C. And then you have an LED for X. And you can see the truth table. This is the truth table. Many of you are familiar with the truth table from digital systems class or introduction to engineering technology class. In this truth table, basically, you are going through each input condition from 0, 0, 0, all the way up to 1, 1, 1. There will be 8 conditions. You have 3 switches. And then you're going to be observing your light. And whatever is the condition at the output, either 0 and 1, then you're going to be filling up this truth table. You're going to create the circuit with the Boolean gates. And remember, Boolean gates are present in the Boolean and comparison library. And I'm putting the numbers of different gate that you see over here that you used in PSpice. The circuit is from PSpice. So I'm putting which number is correspond to what gates. So because in LabVIEW, the name of gates are given, but the number of gates are not given because it's not a circuit simulator. But the name of each gate is given. So make sure you look at the number and then identify the gate and then pick up that gate from the comparison library, where was it? Express, comparison, and Boolean. So here are all the gates right here. So make sure you look at the name of the gate based on the number, and then pick up that gate and connect them together, use 3 switches in the front panel, use an LED in the front panel. And then test all conditions and fill out this table. Now what you can do, again, you can fill out the table and you can just snip this if you want right here. And you can put it in the front panel in the output of the exercise. So you can put it in the front panel and just fill out. Let me go back. And then just fill out. You just fill out with, I don't know if you can, the picture you cannot use text, but you can just fill out in the tutorial and then cut it and then put it in your front panel so that I can see that these are your results. I can always, of course, fill up the switches and look at the LED, but I want you to fill out the truth table as well and then put it over here. The other way you can do that if you want to is you also have list table entries. So you can just put a table, for example, and then do A, B, C, and X, and then just create a table over here. But if you do that, then make sure you do the right click on the table and then go to data operations, and then you do make current values default. Because anytime you are filling out a table or producing a matrix or a graph, and if you don't make the values that you're defining in that table or matrix or arrays, if you don't define those and save it by making the current values default, then every time you run the program again, the data is going to be erased. So anytime you want to keep the data in a table or array, what we're going to discuss next week, you have to make the current values default. So once you fill this table out, make the current value default. I would say the easy thing is going to be just as the table is already there in the tutorial. Just fill this table out. If you're using Microsoft Edge, you can use the typewriter in Microsoft Edge PDF. I'm using Foxit. I can use typewriter. If you're using Adobe Photoshop, Adobe Reader, Acrobat Reader, you can use text. So I can just fill out, let's say 1, 0, 0, 0, 0, whatever the values are. I can just fill it out here, and then I can snip it and then paste it with exercise 11. So you're going to have 3 switches, 1 LED, and this table as part of your exercise 11. And that concludes today's meeting, pretty much. I don't think we are doing anything else. The rest of the stuff that we have to do is part of next week. So we're just going to discuss that next week, which is not that much. So next week class should also be a shorter class. If you have any question, please feel free to ask me about anything that you have done either so far or any other question from today's lecture. Of course, the lecture is recorded as well. That will be posted as well. Okay, seems like there is no question. Let me go ahead and stop recording.